Bad back.
Phrases, I'm good.
No, I was in.
Bad back.
Okay, why did we
Bad back.
Okay, let's continue and let's continue. We're gonna take a look at number 9, and number 9 is, a bunch of Riemann sums. So we have a right rectangle, a left rectangle, and a midpoint approximation. Okay, and then the average velocity. So number 9, let's make that chart again. It's going to be very similar. Interval. So the first interval, we're just going from 0 to 4 again. One to 2, 2 to 3, 3 to 4. The next is going to be the height. Sorry, we're doing part A here, which is the right rectangular approximation. Okay. So in the right rectangle, we're going to get the height. The width is going to be all 1s, and the height is going to be f of xr. So the x-coordinate on the right. So what's on the right of 0 and 1? 1. What's the height at 1? 4. And then 8, and then 5, and then 3. And this is specific to the right rectangle, so now we can write our integral. The integral, from 0 to 4 of f of x dx can be approximated by 1 times 4 plus 1 times 8, 1 times 5, 1 times 3. So it's approximately equal to 12, 17, 21. Good. B, right rectangles. No, left rectangles. What? B, left rectangles. No. Yeah, no. Gonna get all of you. What happened? Okay, everything is exactly the same except for taking the height. Instead of the height, we're going to take the height at the left side. Okay. So in the left, I can't add? 12 plus 8 is 20. Why'd I listen to this guy?
Yes.
You chose.
Wait, 12 plus. Oh.
Oops. 1485. 1, 4, 8, 5. Yeah, it's really similar. The only difference is you're taking the height at the left side instead of the right side. For example, for this first interval from 0 to 1, the left side is 0, so the height at 0 is 1. Integral from 0 to 4 of f of x dx can be approximated by, again, 1 times 1 plus 1 times 4 plus 1 times 8 plus 1 times 5, 1, 5, 13, 18.
Are you sure?
Okay, part C. Part C, we're supposed to use midpoint rectangles, right?
Oh, I like that one.
Okay, so for midpoint rectangles, we only need 2 rectangles now.
0 to 2 and 2 to 4.
So yeah, 0 to 2 and 2 to 4. No, not yeah, 0 to 2. And then 2 to 4. So the width is going to be different now. Now this width is 2. And the height is going to be the height at the middle. We're not there. No, I haven't done it yet.
5, so it's going to be...
Okay, so between 0 and 2 is 1. The height at 1 is 4. Between 2 and 4 is f of 3. The height at f of 3 is 5. Okay, so the integral from 0 to 4, f of x dx, can be approximated by 2 times 4 plus 2 times 5.
18.
18. Good. 18.
Sure, Brian?
Okay, so if this is actually a velocity function, then we can find the average velocity. So the average, again, the average is going to be equal to 1 over
4 minus 0.
yeah, 4 minus 0 times the integral from 0 to 4 of f of x dx. Okay, well, we did that integral, and from part D we got 18. And so the average is equal to 1/4 of 18, which is 4.5.
Stop.
It is 4.5, right?
I said that.
Okay. 10.
Wait, where'd the 18 come from?
Part D.
Above.
Or I mean, from part C.
Oh.
From part C. All right. Maybe I should pause here and make sure that we're all okay. Any questions? Yeah. No, probably going to end this around 4:45, in 15 minutes or so. Okay, let's take a look at number 10. The product of two numbers is 800. Okay, we don't know what the two numbers are, so we'll use x and y. X times y equals 100. 800, sure, why not? Find the two numbers if the sum of 2 times the first and 3 times the second is the minimum. So I want 2 times the first plus 4 times the second. I want that to be a minimum.
3 times the second.
Sure, whatever. We're going to solve here. We're going to say y equals 800 over x. So now we can substitute that in here and say f is going to be equal to 2x times 2400 over x. Hey, I just forgot to write it. It's okay. Did I actually say times?
Yeah.
Yeah, I did say times. Okay.
I get it.
This we want to minimize. So we're going to take a derivative. We use our minimization. Oh, we should get a... Oh, no, there is no boundary here, is there? X can go infinitely. Okay, so f prime of x is 2 minus 2400 over x squared. Do you need help with that derivative?
Yes. Actually, no. Yes.
That's why it works.
Oh, okay.
F prime of x, I'm going to turn this into a rational expression. That's going to be 2x squared minus 1200 over x squared. That means I'm going to have critical numbers. Critical numbers are going to be 0.
Wait, isn't it radical 1200?
Hmm?
What are you saying?
20
Oh no, these are right.
rad 3,
Simplify that. Yeah.
negative 20 rad 3.
How do you bring it out again?
Set the numerator equal to 0.
The top and the bottom is 0.
The top and the bottom.
You do that thingy where you split it up, just factor it.
Okay, well, we know the numbers are positive, right? We know the numbers are positive, so these guys are dead. Let's just make sure I have an actual positive relative maximum. We're going to make our number line. Okay. So from 0 to 20 rad 3, then from 20 rad 3 to positive infinity. We're just making sure we get a relative maximum. Okay. So give me a number between 0 and 20 rad 3. 1, good. 1, we have 1 minus 1200 is negative. Negative over positive is negative. Give me a number between 20 rad 3 and
20 rad 4.
21. No.
It's just 4.
it's definitely not 21.
23. 100.
100, good. 100 squared is 10,000. 10,000 minus 1200 is positive over a positive number. So we have a relative minimum. Sorry, one more thing. Remember that y is equal to 1 over x times 800. So y is going to be 1 over 20 root 3 times 800. So y is equal to, what is that, 40 over root 3?
Yeah. Which is 40 root 3.
So there is a minimum at 20 root 3 and 40 root 3 over 3. That's where I get my minimum. Oh, look at this. The base of a solid is between x squared and x equals 4. Okay, so I think for this one we're going to have to look at the base. This is probably going to be the last one we do.
Yeah.
So let's look at the base. The base is going to be sure. I'll pause here for a couple seconds. Sorry. Check my email. Sounds great. We should be in town on the 20th. I'm sure I could slip away for lunch or dinner on a day after that. Do you have any days off that work?
Party at friends. Are we invited?
Do you want to hang out with Mike Uno and Taka Ishiki?
Yes. Wherever they are.
They're pretty cool dudes.
They sound very cool.
We're gonna get together and we're gonna talk about Electron. Or
You guys gonna jam?
no, we could, but we never have.
Oh, you should. Spirit at a.
Michael plays the cello, and he plays the drums.
You play the drums.
Taka plays a little bit of guitar, and he plays the clarinet.
You can make like a different type. Yeah, you could do.
Taka and Mike were both drum majors.
Let's be. Sorry, I'll stop.
She's the best person on the planet.
Okay, let's finish this out. The base is going to be x. The base is going to be on the curve x equals y squared. Okay. So we're going to have to actually look at it like this. Y equals positive root x and y equals negative root x. The cross sections are going to go from the blue curve to the yellow curve. So this is one of the cross sections. We'll call that L. So L is going to be equal to root x minus negative root x, which is, Brian? Thank you. 2 radical x. The next thing is to look at the cross sections. Hello. The cross sections are triangles with an altitude of 2.
Can you go back up for a second?
Sure. Cross sections.
Took me like 2 tries.
So let's draw a triangle with an altitude of 2. Ooh, whoa.
That's fancy.
I can't do that. I can barely draw straight.
I get computer aid here. Okay, that's my L, right? And then the height here, the altitude here is 2. So the key is to figure out the, oh, you know, I forgot a line here. I forgot x equals 4.
First try, 2, 3, and try.
Sorry about that. Okay, what is the area of the cross section?
Half 2 times L. He's writing it out.
That's my cross section, right? And if we've learned anything, we know that all we need to do is integrate the cross-sectional area. Integrate L dx. What is the minimum value of x? Good. What's the maximum? Good.
Oh, I didn't see that.
X equals 4.
0 to 4 of L. Ooh, what was L 2 root x?
Yeah.
The line x equals 4. That's like the...
This is x is 1/2. 1/2 plus 1 is 3/2. Reciprocal of 3/2 is 2/3. 2/3 times 2. 4/3. Good. This is 4/3 to the 3/2. We're going from 0 to 4. Whoa, why did I write an A here? That's a V. No pi. No circles. Alright, square root of 4. 2 cubed. 8 times 4. Good. 32 over 3 minus square root of 0. Good, we're done. 32 thirds.
Actually, it wasn't that hard.
All you do is find the integrate cross-sectional area.
That's all.
That's all. Okay, that's where we're going to stop today.